On the night of December 18, 2019, in the mountains of northern Chile, a telescope was quietly photographing the same crowded patch of sky over and over again. Thousands of stars, none of them doing anything interesting. Except one. For about an hour, a single star began to brighten. Not a flare, not an explosion, a smooth, perfectly symmetrical swell of light that rose, peaked, and faded away, like something had passed slowly in front of it, and then kept moving. By the next night it was back to normal. It has never flickered again. Nothing about that star changed. Something invisible drifted between it and us, bent its light, and vanished back into the dark. 6 years later, a team finally worked out what that something might have been. And the leading answer is an object older than every star in the sky, possibly made of the one substance we've never been able to find. They call it Phoebe. To understand why Phoebe matters, you need one idea. And it's a strange one. Gravity bends light, mass warps the space around it, and anything passing through that warped space, including a beam of starlight, gets nudged off its straight path. When a massive object drifts directly between you and a distant star, the bent light gets focused, briefly, toward your eye. For a little while, the background star appears to brighten. Then, as the object moves on, the focusing fades and the star dims back to normal. Astronomers call this gravitational microlensing. And here is the part that makes it extraordinary. It does not care whether the object in front is glowing. The lensing comes from mass alone, from gravity alone. The thing doing the bending can be completely, perfectly dark. It can emit no light, reflect no light, give off nothing at all, and microlensing will still reveal it, because you're not seeing the object. You're seeing what its gravity does to something behind it. It is, in other words, the only tool we have for spotting things that are truly invisible. Which means the question becomes, what invisible thing passed in front of that star? The data sat untouched for years. It had been collected by a project called AMPM, the Asteroid Mass Primordial Black Hole Microlensing Survey, using the dark energy camera mounted on the 4-meter Victor Blanco telescope at Cerro Tololo. The camera had stared at the large Magellanic Cloud, a small companion galaxy to our own, for 5 straight nights, hunting for exactly these brief flickers. When a team led by Renee Key at Swinburne University in Melbourne combed back through it, they found one. A clean, textbook microlensing event. Now, microlensing has been seen before, and the usual suspects are mundane. A faint, dim star you can't otherwise detect. A dead stellar remnant. A rogue planet wandering between the stars. The default assumption is always, it's something ordinary we simply couldn't see directly. So they ran the numbers on what kind of object would produce this exact signal. The answer did not match any of the ordinary suspects. They named the event Phoebe, and it broke the pattern in almost every way. Start with how long it lasted. Most microlensing events play out over days, weeks, sometimes months, because the objects causing them are reasonably heavy and the alignment takes time to drift apart. Phoebe lasted about 60 minutes. It is among the fastest microlensing signals ever recorded. A flicker that brief points to something tiny. When the team modeled it, the mass came out at roughly 3 times the mass of our moon. Not 3 times the sun. 3 moons? Now hold those two facts together. If that mass were packed into a black hole, the entire object would be smaller than a grain of sand, something you could balance on a fingertip, with the gravitational pull of 3 moons folded inside it. An object that's small should not be able to exist. Here's why none of the easy answers work. First, it's far too light to be an ordinary black hole. Black holes form when massive stars collapse, and that process can't produce anything close to 3 lunar masses. The lightest black hole the universe knows how to build the normal way is several times heavier than our entire sun. Phoebe is millions of times lighter than that floor. Second, it showed up in the wrong neighborhood. The analysis places the lensing object not down in the crowded disk of the galaxy where stars and planets are common, but out in the Milky Way's vast, sparse halo, where there's almost nothing to bump into. Third, and this is the number that stopped them when they compared the possibilities statistically, the object came out around 100,000 times more likely to belong to the dark matter of the halo than to any normal population of stars or planets. And fourth, There was an alternative almost as wild. If Phoebe sits inside the Large Magellanic Cloud instead, it would be the first planet ever detected in another galaxy. Whatever Phoebe is, it is not ordinary. So the team landed on the explanation the math kept pointing at. The leading candidate for what passed in front of that star is a primordial black hole, not a collapsed star. Something far older and far stranger. A black hole that was never a star at all, forged in the first fraction of a second after the Big Bang, when the infant universe was so dense that regions of raw energy could pinch themselves shut into black holes directly with no star required. They could come in almost any size, including tiny, including 3 moons worth of mass crushed into a speck. For decades, these objects have been purely theoretical, predicted on paper, never confirmed. Phoebe may be one of them, caught in the act of bending starlight for a single hour 6 years ago by accident. And if it is, it isn't just a strange object. It might be a piece of the biggest missing thing in all of science, because of what primordial black holes could be made to explain. Roughly 85% of all the matter in the universe is invisible. We can't see it, can't touch it, can't catch it in any detector we've built. We only know it's there because galaxies spin too fast to hold themselves together without some unseen mass anchoring them. We call this missing ingredient dark matter. And after half a century of searching, we still have no idea what it actually is. The leading guess was always that dark matter is some exotic, undiscovered particle. We built enormous, ultra-sensitive experiments to catch one. Decade after decade, they caught nothing, which has pushed some cosmologists back toward an older, stranger idea. What if dark matter isn't a new particle at all? What if it's countless tiny black holes left over from the birth of the universe, drifting invisibly through every galaxy? Phoebe might be the first one we've ever seen, and Phoebe isn't standing entirely alone. Around the same time, a separate team using Japan's Subaru telescope reported roughly a dozen similar flicker candidates in the direction of Andromeda, our nearest large neighbor galaxy, all pointing at the same kind of small, dark, compact object. The hints are starting to cluster. It would be easy to oversell this. So let's be honest about where the science actually stands. None of these detections is a confirmed primordial black hole. Each one is a single brief event, and a single event can be a fluke, a glitch, or a rare ordinary object caught at a weird angle. What's real is the pattern forming underneath them. Independent teams, different instruments, different galaxies, keep turning up the same strange signal. That's not proof, but it's the way a genuine discovery usually begins, as a handful of anomalies nobody can quite dismiss. The question now isn't whether to take it seriously, it's where the evidence leads next. But step back for a second. If Phoebe really is a primordial black hole, that raises a question stranger than the flicker itself. How do you make a black hole without a star? And how could something born in the universe's first instant still be drifting past us today? The answer reaches all the way back to the beginning of time. The idea was first floated in the 1960s by 2 Soviet physicists, Yakov Zeldovich and Igor Novikov, and later developed by Stephen Hawking. They were asking a simple question: does it take a dying star to make a black hole? And they realized the answer was no. In the first sliver of a second after the Big Bang, the universe was almost unimaginably dense and hot, and it wasn't perfectly smooth. There were ripples, regions slightly denser than their surroundings. In a universe that crushed together, a dense enough ripple wouldn't need a star to collapse. It could simply seal itself off then and there into a black hole. These would be black holes with no stellar parent. Black holes as old as time itself. And crucially, they could be any size. A collapsing star sets a minimum mass. The early universe didn't. A primordial black hole could be as heavy as a mountain range, or as light as a few moons, formed in an instant, and then left to wander, untouched, for 13 billion years. If enough of them formed back then, they could quietly add up to all the dark matter holding the galaxies together. That's the theory Phoebe is testing, and Phoebe isn't the only recent hint nudging this idea forward. In November 2025, the gravitational wave detector LIGO picked up a signal from 2 objects spiraling together and merging, an event labeled S251112 centimeters. When a team at the University of Miami, led by Nico Capilouti, examined it, they found something odd. At least one of the objects looked too light to be a normal black hole, sitting below the mass a collapsing star can produce. The same impossible lightness problem as Phoebe, from a completely different instrument, listening to ripples in space-time instead of watching bent starlight. Their proposal was that this, too, might be primordial black holes colliding. Possible first evidence of the same ancient objects, caught a second way. Put it together and you get a genuinely startling possibility. The invisible scaffolding of every galaxy, the dark matter we've hunted for 50 years, might not be waiting in some particle physics experiment. It might be a swarm of tiny, ancient black holes, and we may have just felt two of them collide and watched a third one pass in front of a star. The paper, it's worth saying, is still preliminary, but the door is open. None of this is settled. Phoebe's discovery paper hasn't yet passed peer review. The leading interpretation is a primordial black hole, but a lone rogue planet drifting through the halo remains genuinely possible, and a single flicker can't rule that out. What it takes now is more events, more flickers, more candidates, until the pattern either hardens into proof or dissolves. Either way, we learn something real about the dark. And that's worth watching closely. A decade ago, the dark matter at the heart of every galaxy was a question we could only ask about in theory. Now we have an hour-long flicker from 2019, a gravitational wave from 2025, and a dozen candidates near Andromeda, all whispering the same impossible answer. That's how fast the picture is shifting. So what do you think Phoebe really was? An ancient black hole, or a lonely wandering world? Tell me in the comments, and if this is your kind of mystery, subscribe.